Hello everyone. In this video, we are going to talk about empirical rule. So whenever the empirical rule comes into the picture, we are talking about the normally distributed data. So always keep in mind, empirical rule is applies on only on the normally distributed data. So when I say normally distributed data, this data is like something like this, which is a kind of a bell curve, a complete bell curve. Okay, and where the mean and median is equal. Uh, so so empirical rule is always being applied to the normally distributed data. So so the empirical rule is also being called as the 68, 95, and 99.7 rule. So in mathematics, the empirical rule says that in a normally distributed data, uh, every piece of data will fall under three standard deviation of the mean. So where the mean is the average of the all the numbers within the set. So what does it says is like if you look at the first diagram, so it says like within the first standard deviation from the mean, 68% of the data set is present inside this range. Okay, so let's say this is the median, and this is the mean or median. Okay, so when you move one standard deviation towards the left and one standard deviation towards the right, okay, so we can say that 68% of the data lies within this particular range. Then comes the second part. Second part is like if you move two standard deviation uh, towards left and two standard deviation towards right, so you can say 95% of data lies within this particular range, and nearly all the data. Okay, you can say 99.7% data falls within the three standard deviations of the data. Okay, so the 0.3% you can say is used to be account for a kind of an outliers which exist in almost all the data. So this is about the normally distribution data. Okay, this is about the empirical rule. So please remember this 68%, 95%, and 99.7%. Now let's look at the empirical rule from with a simple example. So height of the people in Netherlands is let's say the mean of the height of people in Netherlands is 70 inches, and standard deviation is 3 inches. Okay, so within one standard deviation, the range is equal to 70 minus 3. Okay, so one standard deviation is means like we are calculating the one standard deviation. So 70 minus 3 is equal to 67. 70 plus 3 is 73. So we can say that 68% of the people are between 67 inches to 73 inches. Similar way, within two standard deviations, we can just subtract to get the range. 70 minus 2 multiplied by 3, 64 inches. 70 plus 2 multiplied by 3, 76 inches. So we can say the 95% of the mean are between 90% of the men or the people are between 64 inches and 76 inches. Similar way, 70 minus 3 into 3 within three standard deviations if we are calculating. So it will be the minimum value will be 61 inches and the maximum will be 79 inches. So we can say 99.7% of the people are between 61 inches to 79 inches. So the same, the case of height of the people we saw. Okay, so here we have the mean is equal to 70 inches and standard deviation is equal to 3 inches. So we can see here, this line is the 70 inches is the mean. Okay, now we have this 67 inches and 73 inches. Okay, within one standard deviation, you can see here from here one standard deviation 67 to 73. So 68% of the data will be lying between this purple range. Okay, then we have the 95% data, which is the green line. Okay, so which is basically two standard deviations. So 95% of the data will fall within this, and then the remaining 99.7% is with the yellow line. Okay, which is the within three standard deviation. So where the range is 61 minus 71, 61 to 79, 61 to 79, and this is the mean. So this is how the empirical formula is being tells us about the normally distributed data. Please keep in mind three things, like we have to always consider the mean and we have to also consider the standard deviation. So in a normally distributed data, if we move if within one standard deviation 68% of the data lies, within two standard deviation 95% of the data lies, and within three standard deviation 99.7% of the data is being database lies. Okay, so it's like it's very important, useful for forecasting outcomes within a data set. uh, so so it's like it helps us to understand the range of the values, and we can do a lot when we know the range and the distribution of the data accordingly. So this was all about the empirical rule. Please let me know if you have any questions in the comment section. Thanks a lot.